Okay, here we are in 8.4 on compound interest. What you're going to learn in this section is how to use compound interest formulas, how to calculate the present value, and understand and compute effective annual yield. Now, computing the compound interest, you're doing it on the original principal as well as on any accumulated interest. So calculating the amount and account for a compound interest paid once per year, you're going to use the following equation. So if you deposit, say, P dollars at a rate of R, now make sure remember to convert it to decimal form. So you know it's going to give you as a 5%, but you have to put it as 0.05. Subject to compound interest, then the amount A, which is our future value of the money in the account after T years, is given by future value equals the principal times 1 plus the rate to the power T. Okay, so the amount A again is future value, P is the principal, R is the rate, and T is the amount of time. So here, example, you deposit $1,000 in an account at a bank that has a rate of 1.4%. Find the amount A of money in the account after 5 years, subject to interest compounded once per year, round to the nearest cent. All right, so what do we have? So first, we have our formula A equals P times 1 plus R to the T. Our principal is 1,000. 1 plus our rate is the 1.4%, so that's going to be 0.014, and it's to the power 5. All right, so now let's go do our calculator and see what that equals. So let's clear that out. So we have 1,000 times 1 plus 0.014 to the power 5. And that gives us 1,071.99. So let's go write that down. So we get 1,071.99. So that's what our future value is going to be. 2 says find the interest we earned. Well, if we started with $1,000 and we're now at 1,071.99, that means if we subtract those, we should get 71.99 as much as our interest is equal to our interest. So that's how much interest we earned because we went from 1,000 to 1,071.99. All right. Now, what if it's just not compounded once per year? What if it's compounded multiple times? So then we have to look at the compounding period, which is the period of time between two interest payments. Now, interest is paid in times per year. So in can be a lot of different things. It could be semi-annual, annual, monthly, quarterly, however we decide to do it. So first one we have is compounded annually. And so when it's paid once per year, the compounding period is n is equal to 1. Semi-annually, it's paid twice per year and it's compounded every 6 months, so n is 2. Quarterly, when the compound interest is paid 4 times per year, the compounding period is every 3 months, or n is equal to 4. And if it's monthly compounding, guess what? It's paid every month, so n is 12. And if it's daily compounding, we're going to go back to the banker's rule and say n is equal to 360. So calculating the amount of the account compounded in times per year is going to give us a slightly different formula that we have to learn. Now, do we have to learn this formula as well as this formula? No, we can forget this formula and only use this formula if we want to, because when we have compounded once per year, n is 1, and we get back our original equation that we had at the first one. So we only have to really remember this one equation. And so basically, their future value is going to be the principal times 1 plus the rate in the decimal form divided by the number of times it's compounded per year raised to the power number of times it's compounded per year times the number of years you're doing it. And so that's the formula we're going to use to figure out the interest when it was compounded in times per year. So, for example, if you deposit $4,200 in an account that has a rate of 1.6%, the interest is compounded quarterly. So, what does quarterly mean? Well, remember that was n is equal to 4. Then find how much money you will have after 10 years and round to the nearest penny. All right, so we have A is equal to P times 1 plus R over N to the NT. Okay, so again, P in this case is going to be our $4,200. And so we'll have that equals 4,200 times 1 plus our rate is 0.016 as a decimal divided by N, which is 4, raised to the 4 times, and we did it 10 years. Okay. And so now we're going to plug all of that into our calculator. And so let's clear that up. So now we have the 4,200 times 1 plus, now that was 0.016 divided by 4, and then that was raised to the power 4 times 10, and then we can say enter, and so we get $4,927.17. That 9 rounds the 3 up to 3, 3 doesn't round to 7, so that's where we're at. So we get $4,927.17. Now, how much interest did we get? Well, 2. This one's not as easy because you have 4,200 from that. So what we're really going to do is we're going to take 4927.17 minus 4,200. And that's going to give us 17. That's going to give us 7. That's going to give us 2. And that's going to give us a 7. So we get $727.17 in interest. So that's the interest, and that's our future value. Okay. All right. So let's stop there, and we'll come back and look at it continuously compounding. This was compounding monthly or daily or yearly or whatever, and we'll look at continuous compounding.